So today we're going to go over an example problem involving instantaneous velocity and average velocity. This question is pretty wordy. I'm not going to read it all out loud. Feel free to pause the video and read it yourself if you want. But essentially it's just a cheetah running in a straight line. So step one is going to be to identify our givens. So first off, they say the cheetah starts 20 meters east of the vehicle. And then it says during the time t equals 0 to t equals 2 seconds, the cheetah's x-coordinate varies via this equation below. Now that we have our givens, our next step is to identify what we're solving for. So part A asks us to find the displacement between t1 and t2. And then part B wants us to find the average velocity between t1 and t2. And then part C wants us to find the instantaneous velocity at t1 equals 1.0 seconds using delta t equals 0.1, delta t equals 0.01, and then delta t equals 0.001. We'll probably just do delta t equals 0.1 for this example. And then lastly, part D wants us to find the equation for the instantaneous velocity and then use that equation to find the instantaneous velocity at t equals 1 second and then t equals 2 seconds. We'll probably just do t equals 1 second for this example. So now that we identify what we need to solve for, the next step is to identify the equations needed to solve. So for part A, we're finding the displacement. So we're going to need the equation to find the position of the cheetah at the two different points. And then we need the displacement equation, which I also put there. And then for part B, we're finding the average velocity. So we're going to need the average velocity equation given there. And then part C wants us to find the instantaneous velocity using the delta t's given. So we're going to need the limit version of the equation. And then part D wants to find us the equation for the instantaneous velocity. So we're going to need to use the derivative equation. So we have everything set up now. The only thing to do now is just to solve. So as I said before, part A, we're finding the displacement. So we need the displacement equation as well as the equation for the position. So we can start by finding x1, which happens at t1 equal 1.0 seconds. So we just plug that into the position equation. And then we have to square the time. So it turns into 1.0 seconds squared. I just want to note that we have to square both the units too and the amplitude. So I show a little figure below how that works. And then if we do the multiplication, we get 5 meters. And I just want to note how we get just 5 meters through the unit multiplication. You got to make sure that we're multiplying the units as well. And so when we multiply meters per second squared by second squared, the second squareds cancel, and we're just left with 5 meters. Then we also have to find x2, which happens at t2 equals 2 seconds. So we just follow the same process as x1, except we're plugging in 2 seconds instead of 1 second for the time. And we do the same unit multiplication. Thus, when we do 5 meters per second times 4.0 seconds squared, we end up getting just meters. And we get the final answer for x2 equal to 40 meters. So now that we have the positions at t2 and t1, we could now find the displacement. So we can write down the displacement equation and then plug in our values, and we get 15 meters as the total displacement of the cheetah during that time period. And this video is getting kind of long, so I'm going to turn this into a two-parter. My next post will be on part 2, finishing this problem. Feel free to let me know if you have any questions of what I did so far.